Hi, we're going to talk about another stress on a system in equilibrium. So this is LeChatelier's principle when we have a change of pressure. Now, I really like my students to figure things out. I'm sorry, I'm going to tell you right out of the gate. You just have to straight up memorize this. I will tell you the theory behind it, but honestly, I think it's probably just easier memorizing it. I'm sorry, one of the few times that I say, hey, just memorize it cold. All right, so here it is. If you increase the pressure of a system, it is going to shift to the side with the fewest gas moles. Now I know that it seems a little opposite, so you increase, you think more, and yet it goes to fewest gas moles. I'll explain. Here's a second, the counterpart to this that you have to memorize. If you decrease the pressure of a system, it is going to shift to the side with the greatest number of gas moles. So here's the reason why. Let's come to this first one. So if I increase pressure, remember increasing pressure means I decrease volume. Increasing pressure, you know what pressure is. It's going to be force per unit area. So these gas molecules, it means that there's more collisions on the side of the container, okay? So if I have more collisions, by increasing the pressure, we've got to try and decrease those collisions. How do you do that? Well, you shift to the side with the fewest gas moles. There will be fewer gas moles to collide, so it decreases the pressure. Likewise, here, if I decrease the pressure, so I'm going to open this up, I make the volume larger, decrease the pressure, there's fewer collisions. So to bring it back into equilibrium, then I have to get the greatest number of gas moles, go to the side with more gas moles to try and get more collisions and bring this back into equilibrium. So there's the thought process behind it, but again, I would memorize those two. So I like to do several examples with you. Let's first look at this carbon monoxide plus 3 moles of hydrogen in equilibrium with 1 mole of methane and 1 mole of water. Let's say that we're going to increase the pressure. Now, a trick to this. Here's how a question could be asked. It could say, which way will this shift to regain equilibrium if you decrease the volume? They'll talk about volume instead of pressure. So let's go back to Boyle's law. You'll recall the relationship. As you increase pressure, you decrease volume, and equally true, opposite but equally true, if you decrease the pressure, you increase the volume. Think about a piston inside of a car. I decrease the volume, the pressure goes up. The gas molecules are closer, there's more collisions. I increase the volume of this cylinder, the pressure decreases because there's more surface area for those collisions to happen. So remember this, if you're asked a question about volume, that's their backdoor sneaky way of saying, hey, we're changing pressure. So if we decrease volume, that means we increase pressure. Okay, so then I have memorized, all right, if I increase pressure, it's got to go to the side with fewest gas moles. So let's count gas moles. I've got you only count gas, you won't count aqueous, liquid, or solid. So I've got 1, 2, 3, 4. So 1 plus 3, 4. We've got 4 moles of gas on the reactant side, and I've got 1 plus 1, 2 moles of gas on the product side. So again, I increase pressure, is going to go to the side with the fewest gas moles. There it is. 2 is smaller than 4. So this is going to shift forward. It is going to make more of the products. We'll have more collisions with the reactants to consume reactants, produce more products, so that we have fewer gas moles. Okay. Now, let's say that, again, they're kind of tricky, and they increase the volume on us. Okay, so we're going to increase the volume, which means it decreases the pressure. Decrease the pressure. Okay, and then you and I have memorized. All right, if we decrease the pressure, it's going to go to the side with greatest number of gas moles. So again, count those gas moles, 4 moles of reactants, 2 moles of products. These are all gas moles. And decrease pressure, go to the side with greatest number of gas moles. There it is, 4 is greater than 2. So this will go in the reverse direction. It's going to consume the products and make more reactants to get more gas moles.